Alright, so this video is going to be on connective tissues. So connective tissues are very widespread throughout the body. They're in high abundance all throughout the body. So let's just go over a couple of general things about them to begin with. First of all connective tissues are made of two general parts, okay? And those parts are cells and what's called the extracellular matrix. So the extracellular matrix is the components or the materials that surround the cells, okay? Now the extracellular matrix is made up of two things. Those are ground substance, which can look very different from connective tissue to connective tissue. So it just depends on which tissue type you're in as to what that ground substance is going to look like, okay? And the second thing that makes up the extracellular matrix are fibers, okay? Fibers are kind of like rope-like or string-like proteins found within a cell that are typically used to help make up the framework of tissues, okay? So there are three different types of fibers that we can see in these tissues, and it's going to depend on which tissue you're looking at again as to which type of fiber you see, okay? The first type is called collagen. Collagen is typically used for strength, to provide strength to a tissue, okay? Second type of fiber are elastic fibers. So you can probably guess what these are going to provide for. They're going to allow for some stretch to the tissue, okay? Give the tissue some stretch or some flexibility. And the third type of fibers that you can see are reticular fibers. Now these help form a framework within certain organs, okay? So we'll talk about a few of those in just a bit. All right. So ground substance and fibers, those are the two things that help make up the extracellular matrix. And as I told you before, your extracellular matrix is going to differ from connective tissue to connective tissue, okay? It's going to look very different for each one. So let's list out the main categories of connective tissue to begin with. First one is bone. Okay, bone is the most solid form of connective tissue, so we'll start there. Then moving from bone, we'll go to cartilage. And there are three different types of cartilage. Those are hyaline, elastic, and fibrocartilage. Then we'll get into the next type, which is dense connective tissue. And there are a few types of dense connective tissue, okay? We have dense regular connective tissue, dense irregular connective tissue, and what's called elastic connective tissue. Now do not confuse elastic connective tissue with elastic cartilage. Those are two different types of tissue, okay? Then we get into loose connective tissue types. And there are three of these as well. They are areolar connective tissue, adipose connective tissue, and reticular connective tissue. All right. Then we get down to the most fluid form of connective tissue, which is blood. Okay. So these are the types of tissue that we're going to be talking about in this video. So let's go ahead and go up to our first one here. So this tissue is bone tissue. Where is bone tissue going to be found? It's going to be found in your bones, okay? So in the skeletal system. Now this tissue has several functions. It helps provide a framework for the body. It helps provide protection for some of your internal organs. Bone tissue serves as a storage unit for certain minerals like calcium. And it's also very important in providing your blood cells. So blood cell production happens inside of your bone marrow, which is in this tissue. Okay, it's pretty easy tissue to pick out of a lineup. To me, it kind of looks like rings on a tree trunk if you cut a tree down. That's kind of what the image looks like to me, so it makes it pretty easy to pick out. Okay. This next type of tissue is hyaline cartilage. Now this tissue is made of chondrocytes, so you can see those in the picture, and they're found in these kind of little hollow cavities called lacunae. Okay, so this is a lacunae, and you have a chondrocyte inside of that. Chondrocytes are cells of cartilage. Okay, in bone tissue we have what are called osteocytes. Those are the bone cells. So those are these nice little dark spots here. Those also reside in lacunae, okay, within the bone tissue. Now hyaline cartilage, let's get back to this one. Hyaline cartilage is found on the ends of your long bones. So those would be bones of the arms and the legs that help form your joints. And also the cartilage that connects the ribs to the sternum, that's made of hyaline cartilage. The cartilage that covers the front of your larynx is hyaline cartilage, so that's used for protection of that structure and help to form the framework for it. And also the cartilage that makes up your nose is hyaline cartilage. Now specifically when we look at the cartilage, hyaline cartilage covering the ends of the long bones, there it's going to be used to provide a nice smooth surface at that joint. Okay, so those bones aren't kind of grinding against each other as they move in the joint. You have a nice smooth surface for them to glide against each other. Okay. This next type of cartilage is elastic cartilage. Now elastic cartilage helps make up your outer ear and also your epiglottis, which is that little flap that covers your pharynx whenever you swallow food and prevents you from choking. Okay. So elastic cartilage has a lot of springiness to it, a lot of flexibility to it, because it has a lot of elastic fibers in it. If you see all these nice dark purple lines kind of scattered in here, those are lots of elastic fibers. Now you still have the chondrocytes and the lacunae, but there are a lot of elastic fibers surrounding them. If you look back at hyaline cartilage here, you see that there are really no fibers whatsoever. It's just a nice smooth ground substance, kind of like a jelly-like material. In elastic cartilage, you have a lot of those elastic fibers. Okay, so that allows for some flexibility to that tissue. So it gives you some firm support in the tissue, but it also allows for a lot of flexibility. Okay. This next type of cartilage is called fibrocartilage. Now, fibrocartilage is found in your intervertebral discs. Those are found in between your vertebrae, okay? And also the menisci of your knee, your meniscus, is made of fibrocartilage. Now, both of those structures are used for shock absorption. They absorb shock in between the vertebrae or in between the femur and the tibia whenever you're walking, and it prevents those bones from just banging against each other and hopping up and down and hitting each other all day, every day when you walk around or move. Okay, so those are going to allow for a lot of shock absorption. Then we get into the dense connective tissues. Okay, so we're in dense connective tissues here, and we'll start with dense regular connective tissue. So that's what we're looking at here. Now, dense regular connective tissue makes up rope-like structures. So you can see the fibers are regularly arranged. They're nice and parallel to one another. Okay. And this tissue, again, makes up rope-like organ structures. So structures like your tendons and ligaments. Tendons help hold muscle to bone, where it attaches them to bone. Those are very strong, tough structures. Ligaments attach bones to bone. So this tissue is mostly going to be made of collagen fibers. Okay, collagen fibers, which, as I told you before, are used for strength. And this type of tissue allows for a lot of strength in one direction. Just like a rope provides a lot of strength in one direction, because all the fibers are kind of running in one direction, parallel to one another. Now this next one is dense irregular connective tissue. And this one's going to allow for strength in all directions because, as you can see, the fibers are kind of running, some of them are running parallel to one another, and then some of them are kind of running perpendicular. Okay, so you have what's kind of like a lattice pattern happening here rather than, you know, those fibers running nice and parallel to one another. They're more in a crisscross pattern. So that's going to provide a lot of strength in pretty much all directions of the tissue. And this tissue is found in the dermis of your skin, so underneath the epidermis. And it also helps make up some of your joint capsules in the body that kind of surround the joint and help stabilize the joint. Okay. Moving right along, we get to elastic connective tissue. Again, do not confuse elastic connective tissue with elastic cartilage. Okay, those are two different tissues. So this tissue is actually found in some of your large blood vessels, like the large arteries that directly branch off of the heart. And you can see there are tons and tons of elastic fibers in this picture. Those dark purple lines are all elastic fibers. You don't see very many cells in this tissue type. It's mostly made up of elastic fibers. And again, those fibers are used for stretching. Now, in these large arteries, that stretching is important. It gives you some stretch and recoil because those arteries are going to be withstanding a whole lot of pressure all the time, right? Every time your heart beats, there's a lot of pressure in there to push that blood out to get it to the body. And so that blood is just gushing through those arteries. Well, if you had really thin and flimsy arteries or ones that had no elasticity to them whatsoever, they're probably going to rip or tear as the blood flows through them. So this type of tissue allows for some stretch and recoil as the blood moves through those arteries. Okay? Then we get to the loose connective tissue type. So we're starting loose connective tissues here. And this first one is areolar connective tissue. Now, as you could probably see, in these loose connective tissues, you're going to see a lot more white space, open space between the fibers and between the cells that you did not see in those dense connective tissues. All right. So areolar connective tissue, this one specifically is found underneath pretty much all of your epithelial tissues. And its major function is to hold those epithelial tissues into place and help stabilize them. All right. This next one here is adipose tissue. Now, a common name for adipose tissue is fat. You can see the cells in this kind of pink color. I'm kind of outlining some of the cells here. These are called adipocytes, okay? And only the pink part is the cell, interestingly enough. The inside of them, those white droplets, those are called fat droplets or lipid droplets. And their major purpose is for storage of energy, okay? These are going to store energy for us. All right. You also have some insulation provided by this tissue and some, other purposes like protection, but the major one is going to be for storage of energy. Then we get to the next type of loose connective tissue, which is reticular connective tissue. Reticular connective tissue helps form what's called a stroma or a framework of pretty much all of your lymphatic organs. So organs like the lymph nodes and the spleen, ones that are involved in your immune system, those are predominantly going to be made up of reticular connective tissue. And as you might guess, there are lots of reticular fibers in reticular connective tissue. So these nice dark kind of black looking colored fibers are reticular fibers. And remember, I told you guys that reticular fibers are very good at forming a framework within these organs for these cells to kind of mold themselves around, okay? So this tissue forms as a framework in your lymphatic organs for attachment of cells, okay, for those cells. And then the last type of connective tissue we have here, you guessed it, is blood. Okay, so this is a nice blood smear. You can see we have some red blood cells that are all in the kind of light pink color, and they tend to be a little smaller. And then these bigger cells that have the purple nuclei in them, this one, and here's another one here, these are all white blood cells. So the white blood cells are going to be involved in your immune system, okay, helping you fight off diseases. And the red blood cells are involved in helping you to transport nutrients through the body, things like oxygen gas, okay, and other forms of nutrients. All right, so you guys look through these connective tissues, and please let me know if you have any questions about it.